inverse method. What exactly the inverse method is. So far we have solved the questions through the direct method. So what is the direct method? Direct method is that when you have the value of x, when the value of a normal random variable, which is x, this is given, right? And we used to calculate the probabilities. So we are given with x and parameters mu and sigma. That's given. So we just find out the probability. That's the direct. In inverse method, the probabilities are given, and one of them are not given, and you have to find out. So maybe x is not given, maybe one of them, right? Mu is not given, or sigma is not given. So we will see all these three cases, and rest is for your practice, right? So here in inverse method, the probabilities are given and you are being asked to solve the question. Now let's see a question directly from inverse method. So of course in inverse method you have to go in a reversal way. So usually we find the value here because all of these values are given, mu is given, sigma is given, x is given, and you just find out the value of z. But here, this probability is given, and we don't know mu, maybe we don't know x, we don't know sigma, right? So if you open the slides which I have shared with you, you will come across with a question of an inverse method. For example, assume that the aptitude test scores are normally distributed. The mean is 140. Now here mean is given 140, right? Standard deviation is also given. Sigma is given, which is 25 points. Within that interval, x1 and x2. So here interval is given, x2, x1 and x2. Well, it's not, the value is not given. Usually, like for example, in previous lecture, we have this, in previous example, we have this 27 less than x less than 32, right? So here x is given, x1 and x2 are given, but here we don't know. So we just know that it's in between the interval. Sorry. So here the interval is given, but value isn't given. This means probability is given. What is the probability? That is 95%. So it means this area is given, which is 95%, 0.95. So because it's symmetrical, so this area is 0.4475. All right, so 0.95 minus, you can just divide 0.95 divided by 2. So how much is this? 44. Yeah, no, 47, right? So 47.5. And this area is also 0.4750 because of the symmetry, right? You just divide it into 2. So together this one is 0.95, right? Do you understand this one? So this area will be 0.5 less than 0.475, which is 0.025, if I'm not wrong. 0.250. Yeah. Yeah, and this area is also 0.0250. So that's we know. Now we have the probabilities of x1 and x2. This area and this area and this area is also. Right? Now, let's solve it. We know it's symmetrical, so we have calculated these areas. So total area under curve is 1. So remaining, you can get the value. Now, we have to check this 0.4 because here the value is 0.4750. So now you have to check this value in a reversal order in a table, in a Z table. So let me share the slides with you. So if I share the table where now you have to see these are the probabilities given. Now these are the probabilities given, right? So you among these probabilities you have to check where does it lie. So 0.4750. So this is 0.3. So this is a bit of careful work, because if you write the probability against the wrong z value, then it would be problematic. So 0.4750, 475, 479, 474, 4750. So this value. So what is this value against? This value is against 1.9, and here you can see 6. So this value is 1.96. So here the z value, when we see this value in a table, the corresponding z value is 1.96. Because it's on this side, so we add minus. And it's symmetrical, so it is 1.96 plus. Now we got the z value, minus 1.96. We know the formula is x minus mu upon sigma. Now, 3 are given. 1 you have to calculate. So if you have 4 equations and 3 equations are given, 3 parameters are given, you cannot solve it. But if you have like 4 parameter and 4 equations, then you can solve it equally likely, and you can get the fifth one easily. So now you just put the value. So to calculate x1, so this is z1, x1. So we have x1 can be z1 times sigma plus mu, right? So what is x1? Because z1 is on this side, so it's minus 1.96 times 25 plus 140. So if you solve it, you will know that minus 1.96 is equal to 25, right? 49. So it will be minus 49 plus 140, which is 91. So x1 here is 91. And x2 will be same but in an opposite way. So here it will be plus 1.96. So 140 plus 49 is 189. So x2 is 189. So that's how, using inverse method, you can find the missing, right? So here you can calculate x1 and x2. Now, similarly, there is one more thing. For example, let's take a next question from the slides which I have shared with you. So next question, it says, remember one thing. This part is known as confronting part. So sometimes this part isn't given, so you need to take this one as well. So you can solve the next question. Let me share the slides with you so that you can see. I'm just writing down on the whiteboard so that it's easier for you to get. If you don't understand, just let me know and I can start over on the board. Now here, so this one we have solved. This one we have solved, right? Now, in normal distribution, it can also simply tell you to do this, to do in this way. So its normal distribution is given. So here the main thing is to draw the curve, right? That's the main important thing. If you draw the curve rightly, rest is just like a clerical work you need to find out. And because now then you know the procedure, right? So main thing again I'm focusing is that you should be able to extract the information from the questions, because if you correctly get the information from the question, its rest part is really easy for you. If you make mistake during that extraction, then there will be a problem in solving that thing. Now, let's take a normal distribution, where the mean is mu is 140, standard deviation is 25. Find out the percentile value P35, P78, Q1, Q3, right? So I have written this on the board. Yeah, so you need to calculate this one. Now, sometimes remember in this question, standard is, sigma isn't given. Sometimes something else is not given. So it's also, so you don't need to worry about it, right? So if sigma is not given and x is given and mu is given, you will see that how you just calculate the missing one, find the z value in an inverse way, and then just put it in a right way. We will see a little bit in this example. Now, it says P35. What is P35? If you remember the quartile and percentile we have done, so we divide the curve under 100 equal points, and every point is 1%. So in between it will be, because it's 100 equal point and it's a symmetrical, so this will be the 50%, right? Because it's in the center. And of course, now P35, what does that mean? Can be given as P of x is less than equal to x is 35%. That's given, right? Now, because it's less than, so we move from this way to that way. So of course, 35% will be here, right? So this area is 0.350. You can write. And this area, we know whole area is 50%. So what will be this area? It will be 0.15%, right? 15%, and this one is also 50%. So total area under the curve is what? How much? 1, right? So that's how we can get the area here. Now, again, simple thing, you have to do it in inverse. So you have to see this 0.150 to get this value into the table. And when you see it into the table, because it's from this side, so it's negative. So whatever the value of z you will come up, right? So this will be 0, z equal to 0. Now you have to calculate this z1. So the area is 0.150. So now you tell me, look into the table, open the table and see what is the value of this against, what is the value of z against this probability. So if I see it, I can get it now. Okay, let me share screen. Now if you see, you can see the table, right? So this is 0.1480 and this is 0.1517. So I need to get the value of 0.15. So on one side it's 17 unit difference, on the other side it's 20 unit difference. So you can take that unit which has less difference, or you can also take an average. So either you can say, like, what is the value of z against it? There's the fourth row, 1 2 3 4. So it's 0.3. 0.3. Either you can take 8 or you can take 9. Better you can take 9, or you can just take 8 9 8 5. 0.385. So here the value is 0.385 of the at this value, right? The z value. Now you have the z1. You can simply put it into the because on this side, so it should be minus z value. So we know x is not given. So what will be the x when we solve that? X will be the z into sigma plus mu, right? So here it says minus 0.385 times sigma is 25, it's given, mu is 140, it's given. So when you solve it, you can calculate it in your calculator. 0.385 times 25, it gave me 140 minus 9.625. So it will be minus, it will be 130.375. So this is 130. I can take it, I can make it round, and I can just make it 130 approximately. So the 35th percentile so has like 130 random variable of x having 35% possibility that it comes into 35th percentile. So do you understand? Now let's do the similar way. You can calculate percentile of 78. So in percentile of 78, what do you know? You have to calculate probability of x is same given, right? 78 is on that side, so you can either get like x is less than equal to x is less than 78%, right, or greater than 78%. So here 78% lies here, so you can get this one. So from 0.5 minus this one, you can get the value. What is the value here? So yeah, this one and plus. So this 0.5 plus this one, you will get this point, and you can solve in a similar way. Because it's metric, so this area is 0.350, so this area will also be 0.78, right? So that's how you calculate. So Q1 is actually P25. Q3 is equal to P75. So that's how you can calculate it, and I think that you can be able to solve it. Let me give you an example. For example, in P78, percentile of 78, how the graph will be. This area is given, right? This is 140. This is 78 because it's 50% area is on this side, 50% area is this side. So percentile, so 78% should be here, right? Now you have to calculate this area. So total area is 100%. So what is this value? 100 minus 78 is 22%. Now rest is just follow the same way as we did. Let's move to next question. Next question is a bit easier. So here, let's say it's given, the sigma is given, but mu is to need to find out. So in this case, we don't know the mu. X is given, right? It says, for example, in case a sigma is given as 5, but mu you have to find out. Whereas it says that the probability of X is less than 40, 1.5%. Any question? So take the same example, just change the parameter, and you can see. First, now this is given. So here X is given 40, mu we don't know, probability is given 1.5%. So in this case, how will you do? So we know the center point is mu, which we don't know, which is a question mark. Sigma we know. This area, because it's less, see, you can see this value, it's less. So it's moving from this way. So it must be here, 1.5%, right? So X is 40 here, and this area is 0.015. That's 15%, right? So what will be this area? This area will be 0.5 minus 0.015, which is equal to 0.4985. Now look this value in Z table and get the Z value. So tell me, please, now this time you open the table and tell me the value. What is the value against this one, this probability? So you tell me this value. What is the Z value here? I'm waiting. Open the table and see the value. You have to see 0.4985. What's the value? What's the value here? See this, check out this value. What is the Z value against this probability in the table? Who can look? $0.4985. Check this value against the table. It's 2.17. Okay, let me see, because I think it's 2.9. So look at this value, it's 0.4985. Yeah, we are into this value. So there are two 0.4985. So you can choose any one of it. So it's against 2.9, and it's against 0.6 or 0.7. So you can either take 0.6 or you can take these both values, 0.6 or 0.7, or you can take the midpoint, which is 0.675. So I will just take one value, which is 2.96. So I will say 2.96. And because it's on the negative side, so I will just take minus. So now rest is easy. You have x, you have z, you have sigma, you have to find mu. So z sigma equal to x minus mu. Take mu on that side and this one and this side. So mu will be x minus z sigma. So here x minus z is already minus 2.96 and sigma is 5. So x is 40. So minus minus plus 2.9653, almost 15, right? So it gives me almost 15, 2.96 times 5, 14.8. So it gives 54.8. That's our mu. So we can just say 55. So mu here is 55 because you need to round out. So same thing. See, that's how you see the table. Now let's take another example, probably the last one. Where mu, you need to find out the mu. Sigma is a 0.5. Probability of x is greater than 25.48. Equal to 0.025. So that's you need to find out. Now, because it's this sign is greater, so when you're making the distribution, so this one mu, which we don't know, but because this sign, so it means this value should be somewhere here. So the 25.48 should be here, right? So this is the x value. So what is the probability? The greater than probability is 0.025. So it means this is 0.025. So what is this? This is 0.5 minus 0.025, which you give, which will be given again 5, 7, 8, 4, 0.4875. Right? See the value of 0.4875 in the z table and tell me the answer. 0.4875. So it's 2.24. 2.24 plus 2.24. You can easily get now mu, which is x minus z sigma. X is here at 25.48 minus minus 2, and this is sigma, right? So 2 times oh sorry 0.5 2.24 times 0.5, and you can get the value of mu. So that's how we calculate this one. Now, the last one. Here, in this question, this you're gonna solve me and you're gonna tell me. So probability of x is given is greater than 165. Is 96%. Mu is 200, right? Find out the missing parameter, sigma. Now here, sigma is unknown. Can you solve this? Of course you can solve this. This is easy. 200, and because it's greater, so you need to put, because 200 is less than, so 165, so now you need to get this area, right? So to get this area, simple. This is given 96%. So what will be this area? 4%, right? That's 4%. So in this area, this is 50%, 0.5. So you can check 0.5 minus 0.04, and you will get 0.4600. This area is 0.4600. Now check in the table 0.46. What is the value against 0.46? So if I check, I will get 4664 and 56 against 1.8012, 1.825. So z value is 1.825. Because it's on this side, so it should be negative. Now you have all the values, right? 1 point. Oh, sorry, it's 0.459. So it should be 1.7. 0, 1, 2, 3, 4, 5. So it should be 1 point in the table. It should be 1.75. Right. So this is the value. You know x equal to z equal to x minus mu upon sigma. You just put the value sigma, take here, and x minus mu upon z. Here x is 165 minus 200 divided by minus 1.75. So 5 and 35 minus 35 divided by 1.75 minus cancel 0 0. So 3500 divided by 1075, you can easily get it. So 35 divided by 1.75. So sigma is 20. Now you get all the values. Sigma is here, mu is here, probability is here, z is this value. So that's the inverse method. So tomorrow what we will do, so is it clear? Now you're done with the standardized and normal distribution. Is it clear? So this finishes this chapter, and tomorrow we will solve. Oh, let me share again the screen.